Hello again, it is Mr. Ensminger here with another Python video. Today we're going to be doing a few semi-miscellaneous things. We're talking about doing a little bit with loops, but I want to talk about how we can split digits. This is going to be useful for something we're going to be doing coming up in a few weeks, probably next month actually, on looking at place values. We use the base 10 system, so we have the ones place, the tens place, hundreds place, and so on. But a computer uses binary. And when we do this, let's say we have like the number 74, for instance, how do we get, when I say splitting digits, how do we get the 7 and the 4 from that? Mathematically, it's actually not terribly difficult. Let's say we have to get the tens place. To get the tens place, if I want to take, again, let's use 74, if I print 74 divided by 10, that's going to give me 7.4. If you don't believe me, let's just do it real fast. Ta-da, 7.4. I don't want 7.4. What I want is just a 7. So I'm going to drop off the decimal part. And to do that, I'm going to use int. We've seen int in action before. The int is going to drop off any decimal place. So in this case now, the 74 divided by 10, it says 7.4, just give you 7. All right, fantastic. But the ones place. To get the ones place, we're going to use, if you remember back a week or two ago, we did the modulus. It's the remainder. So if I say what is 74 divided by 10 to give me the remainder, in that case, 74 divided by 10 goes in 7 times with a remainder of 4. So in this case, we get 7 and 4. So again, when you have this, to get the tens place, you divide, drop off the decimal, and here, to get the ones place, we can simply use the mod, remembering that mod gives you remainder. If you want to do this with a larger number, it's still the same idea. If you have a 3-digit number, that takes up the hundreds place, which the hundreds place then you divide by 100 or mod by 100, and we'll talk about that later on. But for now, let's just stick with something relatively simple. Let me do some random numbers here since I'm incorporating a few things with loops. So from random import star, and so let me go down here. I'll comment both of those out. It's a little programmer trick. If you don't want that code to run, but you still want it there in your notes, we can just put a little pound sign in front of it. Just keeps it there, but it won't run. So let me generate a number, which is a 3-digit number. So generates a 2-digit number. And in this case, we were talking about 10 to 99. So I want to generate a random number from 10 to 99. So num equals int random times. Now, we talked about this in the past. To get the range, you take the highest number, 99, minus the lowest number, 10, and then you add 1. 99 minus 10, 89, plus 1 is 90. So it's times 90 plus 10. The 90 is the range, the 10 is the lowest number. All right. So let me actually generate 2 numbers, num1 and num2. We'll do the same thing. So I technically should have said generate 2-digit numbers. All right, so what can we do with this? Well, again, I'm going to use a little while loop here. And let me say something like while true, let's say, just to generate a couple of different numbers. So let's end this when the ones place matches. So we're using a while loop. We're also using an if statement. And there's a method in my madness here, so just bear with me. And so if I want the ones place, if num1 mod 10 double equals num2 mod 10, that's when they match up. Okay. So what can we do? We can say something like ones place match, and that'll print that out. when we go. Now, it's not going to end the loop because the loop is infinite. We have while true. But let's just run this, watch what happens. It's going to go really fast. We'll deal with that. And again, I'm kind of programming out loud. Oh no, what happens? It's an infinite loop. It's just printing out one place match constantly. Well, why would that be? Why would that be? Well, let's figure it out. Let's print num1 and num2. So we're printing the two numbers side by side. And when I run this, is it really that it's giving me the ones places all the time? No, see that's what's happening. So let me slow this down on my keyboard. Let me hit the. Oh, that's right. I'm doing this on my laptop, so I don't have a pause key. If you're doing this on a standard keyboard, you're going to notice there's a pause key in the top right corner. On my laptop, it doesn't have one, so I'm going to have to incorporate the sleep command. We'll slow this down a little bit. Up top, we have from random import star. Let's also put in from time import star. And we'll come down here. I'm going to put in sleep. Let's go with like 0.1 perhaps, 10th of a second. Let's try this. There's 80 and 80, one place match. Let's look for another one. Let's see. Oh, they're going so fast, too fast. All right. So if that's not good enough, let's do it, maybe every half of a second, 0.5. Here we go, 65 and 55, one place match. Right. Now, what I have here is an infinite loop. What if I want to say stop the loop when I get a ones place match? Well, there's a command I can use called break. Notice when I type in break, breaks turns orange. Let me run the loop now. Aha. So the loop stops 78, 88. That's the first one where the ones place is matched. There's an 8 in the ones place for both numbers. So our loop has concluded because of the word break. This is one way to do it. You have the word break as part of the if statement. Break will stop the loop. However, another way to do it is, remember that while is kind of like an if statement. It's code that will loop based off of this Boolean condition. It's just that we have the word true there, which means it goes on forever, like we've seen. So one way to do this, let me take this and put it up here. I'm going to copy this. But that's keep going while they are the same. I want to keep going while they're not the same. I want to say keep going while the two numbers are not the matching ones place. Okay. Now, how does that change my program? Well, one thing that's wrong, and we saw this in the last video, because num1 and num2 are not defined yet, meaning we're not generating the numbers until inside the loop, and we're trying to check them on the outside. So going top to bottom, it's checking that code, and it's asking, what are these numbers? And it doesn't know what those numbers are. Well, let's take those two lines, and let's copy them, and we'll put them above the loop. So it generates the two numbers here. Then it checks it. Again, think of the while loop like an if statement. I'm going to take these out for now. My printing, should that stay there? Well, what if the numbers start off as a matching ones place? Well, I'm going to put that up here as well. I know it seems sort of counterintuitive. Like, why would you have all this code that's above the loop? But see, the reason I have it up here is because the first time through, I still have to do it separately from the repeating code. So I put those two numbers out here and then I print them. Then I check them. Now, again, let's just delete the sleep for the moment. And I'm going to actually get rid of this as well. because my if statement really is this. It's just I wrote it as a loop now. So when the loop stops, that means that print ones places match. Okay, so that's back to the left. It's not tabbed in. So like, what should be tabbed in? Well, what should be tabbed in is the next series of numbers. So this is just the first numbers, the first two. What if they don't have a match in one place? Then we have to repeat the code. So I'm going to actually take those and put them inside here. I know it looks weird that the fact that they're duplicated, but that's how you do it. You say, I've got a number, I've got two numbers. First, let's check those first. Then, if they're not a match, I'm going to just keep doing it until I get a match. I have this outside the loop because if the first one's match, I want to skip right down to here. If it matches 5, 6 times from now, if it matches 10 times from now, it'll end and it'll do it right here anyway. So the fact that the loop, the check for it is up at the top, that's what makes the code split up like this. Let's try it out. No, actually, let me put a sleep in here. Sleep 25. All right, let's try it out now. There you go. 31 and 11, the ones places match. Let's try it one more time. There you go. Now that one is actually both the same. How about that? 22 and 22. So there we go. There's an example of doing a while loop and also looking at the digits using either divide with int to chop off the decimal or the ones place. All right, so that's part 1 of the video. Let me save this digit splitter. And then let me go ahead and start a new one here. So for this, I'm going to do something called ASCII and Unicode, which you also sometimes will see as UTF. Those of you that know a little bit about computers, you might know, what's being mentioned here. Back, let's see, 30, 40 years ago, when computers weren't standardized yet, there were different fonts. We still sort of see this today between back when you have like an iPhone and then a friend of yours might have an Android phone. Sometimes when you text an emoji from one to the other, they don't really print the proper emoji because the emoji keyboard doesn't line up between the two different manufacturers. Computers had that problem, but even more so way back in the day before the internet. And so when networking became popular, they had to create what was called the American Standard Code for Information Interchange. ASCII, A-S-C-I-I. It is an alphabet for computers. Everything on your keyboard, whether it's the letters, capital, lowercase, the numbers, the symbols, everything, has a numeric code for each character, letter, number, and everything. Everything has a number with it. The way you access that on your Python programs is with the command CHR. CHR, if you notice, turns purple. And when you do that, notice it says return a Unicode string of 1 character with ordinal I. That's getting a little bit overly complicated. So what does this alphabet look like? Like, how do you know what the alphabet looks like? Well, that's why the internet exists. If I just look up ASCII alphabet chart, let's say, and then let me just pull up one of these images, and obviously you guys are welcome to do the same thing. This might not be the best image ever, but it'll do. So on the left, what you're looking at, those are the numbers in blue. The characters are in this little like teal color. So here, again, here are all the numbers, the symbols. Over on the left side, here are some of the special keys on your keyboard, kind of like the F1 keys and the enter and the space bar and the tab. Because again, like everything on your keyboard has a code that goes with this. Here are some of the lowercase, here are the capitals, and so on and so forth. So if I want to access any of those, I use the CHR command. And if I do like, what's character 78? Let's try it out. Let's run it. Yeah, it's capital letter N. Very exciting, I know. And you're probably wondering, like, oh, well, what's the big deal about that? Who cares? Well, when we talk about things with loops, like if I wanted to print out the entire alphabet, rather than having to sit there and type A, B, C, D, E, F, G, all 26 letters, I could use a loop and print out the different characters. So, for example, let me just say that prints out letter N. Let's do a for loop. This is going to be a loop that's to come. We've talked about while loops, now let's do a for loop. I'll do for n in range 65 to 90. Print character n. And when I run this, there's my alphabets. Now you notice it stopped one letter short. It's actually 91. The last number is exclusive. In other words, it goes up to but does not include that number. We will talk about for loops coming up. Don't worry yourself about it right now, but this is an easy way to write a loop that goes from a number to a number, rather than a while loop, which is based off of like an if statement. This is numeric based. It gives you a nice way to do ranges. So it's perfect for this. I will mention, and again, I know this probably doesn't seem very helpful yet, but you'll see that this is very helpful. The one number you must know, and like we don't ask you to memorize a whole lot, but we want you to know this one. The one number you must know is 65 is capital letter A. The reason you need to know that is because all of the other letters are based off of 65. So if you say, like, what's letter B? B comes after A, so 65, it's 66. But trust me when I say you're going to need to know 65 is capital letter A. Lowercase a is 97. That you don't really need to worry about that one, but trust me when I tell you capital letter A is 65. That's the ASCII alphabet. If you want to go backwards, if you want to say what is the number of a character, there's a command for that as well. You can say print ORD. ORD gives you the Unicode. Now this one, because it's going to think like that's a letter, that's a variable. I have to put it in quotes. So if I do like what's ORD of quote n, well, there you go, 78, which if you go all the way back to the beginning, n. And that's because 78 and n are opposites. So ORD and CHR, those are opposites. But what about Unicode? So ASCII was created back 60s, 70s. It was the popular way of using fonts and characters for a while, but there's also a newer alphabet called Unicode, and that's, like I said, UTF is sort of like the technical term for Unicode. So how do you do Unicode? Well, if I do print \U, and then let me just put in a number like 2556, and you're probably thinking like, where in the world did you get 2556 from? I'll show you in a second. It gives you this little doodad. What is that? I have no idea. But the /U lets you print Unicode characters, and it's followed by a code number. So how do you figure out the code numbers? Well, again, this is not something you really memorize. You're just going to go to the internet. If I do like Unicode character search, if you've ever seen foreign language symbols, math symbols, all kinds of emoji symbols, they're not on your keyboard, but they exist in this character set we call Unicode. And here's a great one, Unicode character search. So then you look up like, what do I want to look up? How about I look up a heart? And then search. And it's going to give you a whole bunch of different outcomes. And over on the right side here, you can see all kinds of different heart. There's a heavy black heart. There's a rotated heavy black heart. There's playing cards. And you see all these little codes over here. You see some of the emojis. A couple with heart, beating heart, 2 hearts, glowing heart, heart with arrows. Oh my gosh, there's so much here. Now here's the good news and bad news. Good news is you can print the 4-digit 2619, 2665. See how these have 2 digits? It's U, and then 2F3C, 2765. Those are the ones that are easy to print in Python. These ones that have 5 digits, like see how this is 1FOB1, 1FOB2, those unfortunately are a little bit tougher to do with what we're using in Python. Those are basically your emojis. And can we do that? There's a way to do it, but we're not going to be able to just with, like I said, the version of Python and everything else that we're running. So unfortunately, some of these we can't do, but let's just go back to these. So a white heart suit, 2661. All right, so if you want to print a white heart, you do /U 2661. The other thing is you can actually copy that. I can highlight that, copy it, and I can put it right into Python. I can say print. And there it is. Like it lets me print that. So if you want to print something that's not on your keyboard, you can look it up and copy it and paste it in. And if it's a Unicode character, it'll print. Now, like I said, unfortunately, if I try and do, let me try and copy this, the 2 hearts. That one works. Let's go down here. So, like I said, it's sort of hit or miss. Let me try another one. See? And like I said, like those of you that have Androids versus iPhones, you see that sometimes. Like if a friend of yours texts you emoji, it doesn't always come up. So I can't guarantee that all of those are going to work. Sometimes when you copy and paste or try the code, it's going to give you that little question mark because it's saying like, I don't know what font you're trying to do. And that's just the way it is. But as I said, if you want to print a Unicode character, you can just say print these codes. And even if the letters are in them, those are still technically digits. There's something called hexadecimal, which we'll learn. And so let's see. Let me do like 2. Oh, I don't know. That's a good one up here. 2F3C. Let's do 2F3C. Print quote / 2F3C. It's going to give me whatever that is. I have no idea. All right, so that's the thing is when you look up here, if I go to Unicode, and then you can go to like an A to Z index, here are all the different things. And I mean, you're welcome to scroll and look at this, but I mean, there's every language on earth is in here, every symbol. Like if you want pi, I can go back here and say, let's do a search. And if I type in something like math pi, search, 0. Well, that's because there is no math pi. It is a Greek letter pi. Oops, that didn't work either. Well, see, the problem is if you type pi, pi's probably going to give you about 10 million results because everything that has a pi in it, like the word capital, has pi in it. Now, if that happens, and again, I'm kind of putzing around here to show you, like, oh my gosh, what happens if I can't find something? Well, you go back to Google and you type Unicode for pi. And what's nice is Google typically has it come up in their first couple matches here. So you see right here, here's pi, so you can copy that if you want to. There's the Unicode for it, 03C0. So if I go back here to my program, 03C0. So quote / U 03. Oh my gosh, I forgot what it was. 03C0. Try that. There we go. There's pi. So if I want to put that in like pi r squared, all you need to do is say something like pi, that's the symbol for pi, comma, quote r, and then squared. And that'll print out pi r squared. Ta-da! So, little miscellaneous thing. We'll be doing some of that in class. But again, it's mostly Google it, look up the number, you figure it out. Thanks for watching. Take care.